6, focusing particularly on some Excel-based problems from Chapter 6, Discrete Probability Distributions. This video, I promise, will be shorter than my last lecture video on this particular topic of Chapter 6. So let's move on to our spreadsheet example here. Let's see if I can get these correctly. There it is. So here I have a number of problems that I have accumulated from your exam, from your textbook, from the first section of the textbook, which deals with probability distributions, which are discrete. So random variable and a probability associated with that variable. So discrete distributions and how we generate a probability distribution table, almost like a frequency distribution table. I mentioned this to you earlier, that a frequency distribution table is always includes a relative frequency. That relative frequency is nothing but the probabilities we are talking about, because remember, one of the ways you define probability according to the classical rule is a number of favorable outcomes divided by the total number of outcomes. And frequency is the total number of frequency, the number that is here divided by the total is the relative frequency. So in this particular problem, which is taken from your 9th edition of the textbook, page 163, number 5, we see a number of calls being made. I guess these are 911 calls, and the frequency of the number of calls, which are where X is the number of calls, the random variable, the frequency is given like this. We actually do not know if it's random, but when they ask us to generate a probability distribution table, we can conclude it's a random distribution, because it's only with a random variable that we do a probability distribution table. Otherwise, we'd be doing a frequency distribution table. So let's use these frequencies to find out the relative frequencies. And remember, the way you find relative frequencies is divide the actual frequency divided by the total. You control the total each time, and then click and drag. You got the relative frequencies. Please copy and paste these. Get these all out from here so that we can actually do all of these things by ourselves. So the probabilities are just the copy and paste of these. Do the paste special because we just use formula. Okay. Whereas the expected value, which is mu in your textbook, that mu, I cannot use the term mu. We do have some Excel spreadsheet language we can use for these. We do have the formulas and all these, but I just prefer to use mu, mu, to denote the Greek letter mu. But anyways, so that's the probability times the random variable X. It assumes a value of 0 here, so that's 0. And if you click and drag, that's probability 2 times 1, probability 0.44 times 2. But expected value is the random variable times the probability. But remember, it is the sum. So you use the sum function. These are for each discrete parts, but you sum them up to get an average. And recall what we discussed in the lecture. These are random variables. These are taking particular probabilities or their chances, which we derive from the relative frequency. So as a result, ladies and gentlemen, we cannot say that this value always has this particular, that this value comes, the number of calls, it's always 1, has a probability of 0.2. It is only in some kind of distributions like the binomial distribution where we say probabilities are fixed. These might vary also. Chances can be that these probabilities also vary. But my point is, why are we doing expected values then? In normal frequency distribution, we did not have to do all these because the values are like that. There is no randomness in the variable. But here we have to do these expected value. And expectation is not a regular arithmetic mean or a regular weighted mean. Expectation is giving you the probability weighted mean. So the probabilities are the chances, ladies and gentlemen. That's why you have to take a summation of the probabilities times the random value. Now, one by one, everything follows 0 minus mu. excuse me, mu is this, and we can also control these. Once we control, you're good to go. It will be controlled for the rest of the numbers. And then with parties, we take a square. Remember, it's the power function. Power function, when you do a square, power of these, what do you raise to the power? 2. That's square. Still not done. How do we get the variance part? We're coming to the variance part one by one. Then we'll take its sum, actually. So that is the variance. So this, again, times the probability, the randomness has to be captured. Yes, that's it, because we have already x minus mu. The mean deviation squared already is there. So do this, take a summation. Let's just reduce the number of decimals for its problem. That's variance, and the standard deviation is square root of variance. Just thinking if this is correct. Expected value. Just have to go through one little thing here. Since everything is good, I just was checking the values with my earlier calculation and making sure that I'm giving you the right number. Seems to be the right number, and I have checked it from another set of Excel spreadsheet. So that's your numbers, and that's your standard deviation, that's your variance. Let's log these out. That's your standard deviation, log these out. So these are your various numbers. So basically you answer the questions. Is a discrete probability distribution, mean number of emergency calls, you put out this number, and variance and standard deviation of calls. The rest of the problems are pretty much the same. We go through the exact same procedure, ladies and gentlemen. This is a example, another example. So you, instead of relative frequency, we directly use the probabilities. This will be given to you in the problems. I'll also be giving all these to you in the problems. Just put the probabilities, expected value, take the summation, that's your mean, then do the mean deviation squared times the probability, and then the summation of to get the variance, and then the standard deviation. Okay. I recall there was one page I had gone over that deals with these. Let's discuss a few more problems before we move on to that particular section. It is college admissions. I have this problem in your problem set that we discussed in the lecture videos. Parking fees. This is another kind of problem. That's same. Just zoom it out a little bit for you all. A bit bigger. Well, that really makes a little bit of difference. Textbook page 164, number 8, 9th edition of the textbook, but you may have it. All these problems in the 10th edition also exist. So look at the probabilities, number of hours, and the frequencies. The number of hours are discrete numbers, and from relative frequency, again, we copy and paste and get the probabilities. What I don't like are too many places of decimals. 2 places of decimals are more than enough. And then there's another amount charged from the customers for parking. It's the same logic. This problem is like how many hours on average at the people parking into the typical customer parking time is approximately 4 hours. See, I took off the 4.14. I'm just saying approximately around 4 hours. And the variance of the hours parked is 4.37. Standard deviation is found like from here. And then the other part of the question deals with how much are people charged for their parking. So there are two parts of this question, and everything, the charged amounts, see, that's the number of parking hours, and the charged amounts are different depending on how many hours you're parking. So that again comes with a frequency and a relative frequencies number. I want to reduce the decimal. And then you find from the relative frequency, you just copy and paste, get the probabilities, the expected value, and how much you're charged for each parking hour that you are taking in that zone. So some of these spreadsheets, numbers in the spreadsheet, instead of showing a minus, can sometimes show something within parentheses. That's the symbol for Excel for a negative sign. And the rest of the problem is pretty much what I just showed you. Just follow the steps one by one, and you should be fine. And then the cola price problem, again, this is a problem I have shown you in your problem set. The sizes of colas and the prices are dependent on the probabilities. Size large, the probabilities of getting largest size at that price, 0.2, then 0.5 medium size cola, and then 0.3 at that price. So you get the expected price of all colas, which is 93 cents, and then you get the variance and the standard deviation by the same method. Maybe can show you the last problem, the bakery cake example, number of cakes. It's kind of, it always makes it so yummy to end off with a problem when you're talking about cakes. So let's just sign this off with one little example here. Cakes sold, the probability of cakes sold is this. So remember, the mean amounts and the standard. Let's keep those amounts, but I just don't want to disturb the format. But mean is as x times px every time. And then you take the summation. Well, I'd already put the formula in, so it came out to be 13.2 is the mean number of cakes sold. And then the mean deviation, 12 minus. Please don't ever forget to put a dollar symbol here, as you have been doing in many of these problems. Once you do the mean deviation, do not have to do any sum product here. By the way, these kind of things are called the sum product in Excel and many other programming problems. And so you just take a power function. So I'm not writing it well enough. 2 raised to the power 2. That's your power function. Okay. The variance, of course, you have to do this times at last the probability, and then get the summation here for the variance and standard deviation. I would say just take the regular standard deviation. Oops. I just have to put the square root to find the standard deviation. Sorry about that. 0.9274. That's it. So mean number of cakes sold, mean number of cakes sold equals 13.2. And then variance and standard deviation, you can finish the problem. So that's about it about discrete distribution. Just follow each steps. You make the like a frequency distribution table, you make the probability distribution table, then find out the mean and the mean deviation to the power 2, the square them, find out the variance by multiplying, taking the sum product, the squared mean deviations with the probabilities, and then take the square root and find out the standard deviation. There is one particular place in your blackboard that I have kind of put all of these together. Let me show you. So on your blackboard, Excel guidelines. This is a discrete distribution in Excel. Gone over the steps by steps in a Word file. There it is. So these are the steps. Excel guidelines are not necessary all the time. If you can follow the steps yourself, this is the steps I'm showing one by one in words what I used in Excel. So sometimes, as I said at the beginning of this class, you can keep them printed out. If you are doing everything in a spreadsheet, it's a handy document to keep alongside how you control for, what's a formula you use, etc., etc. With that, I will end our meeting here, and I will see you with chapter 7.